The air hung heavy in the dimly lit lab. Rows of seismographs hummed, their needles twitching with the Earth's every breath.
Scientists huddled around glowing screens, their faces etched with concentration as they deciphered the cryptic language of seismic waves. These were the sentinels of our planet, listening for the whispers that precede catastrophic roars. They sought to understand the forces that sculpt our world, the forces that can unleash chaos in an instant.
Among the most awe-inspiring and terrifying of these forces are megathrust earthquakes, colossal tremors that arise from the depths of our planet's tectonic plates.
Megathrust earthquakes represent a unique breed of seismic events. They are born from the collision of tectonic plates, the massive slabs of rock that make up the Earth's outer layer. These plates are in constant motion, drifting atop the semi-molten mantle below. Their dance is a slow and relentless waltz, a geological ballet that has shaped our planet for billions of years.
The study of megathrust earthquakes is not merely an academic pursuit, it is a matter of survival. These events have the power to reshape coastlines, topple cities, and trigger tsunamis that can travel thousands of miles.
Understanding their origins, their behavior, and their potential impact is crucial for mitigating the risks they pose to human civilization. The knowledge gleaned from these silent sentinels can mean the difference between life and death for millions living along the Earth's restless margins. The Earth's tectonic plates are not fixed. They're in constant motion. They grind past each other, pull apart, and collide with a slow, inexorable force that belies their immense power.
Megathrust earthquakes occur at convergent plate boundaries, where one plate is forced beneath another in a process known as subduction. Imagine two colossal barges, each carrying a continent's worth of rock, meeting head-on.
The denser of the two plates, typically the oceanic plate, is forced to dip beneath the lighter continental plate. This process is not smooth or steady. Instead, it is characterized by periods of intense friction and sudden violent slips.
As the subducting plate plunges beneath its neighbor, it creates a zone of immense pressure and strain. The rocks along the fault line lock together, preventing the plates from slipping past each other.
Over centuries, stress builds up along this locked zone, like a spring being compressed beyond its limit. When the strain finally exceeds the strength of the rocks, the fault ruptures, unleashing a megathrust earthquake.
The energy released in these events is staggering. Megathrust earthquakes are the most powerful type of earthquake on Earth, capable of generating magnitudes exceeding 9.0 on the Richter scale.
The 2004 Indian Ocean earthquake, which triggered a devastating tsunami that claimed hundreds of thousands of lives, was a stark reminder of the destructive power of these seismic giants. Stretching along the western coast of North America, from Vancouver Island to Northern California, lies a tectonic time bomb, the Cascadia subduction zone. Here, the Juan de Fuca plate, a relatively small but dense oceanic plate, is slowly sliding beneath the North American plate.
The Cascadia subduction zone is a classic example of a megathrust fault. It has all the ingredients necessary for catastrophic earthquakes: a long sloping fault line, a history of intense seismic activity, and a densely populated coastline lying in its potential impact zone.
What makes Cascadia particularly unnerving is its history of long periods of dormancy, punctuated by sudden violent awakenings. Unlike some fault lines that produce frequent smaller earthquakes, Cascadia tends to remain locked for centuries, accumulating stress with each passing year.
When this pent-up energy is finally released, the results are catastrophic. The last major earthquake at Cascadia occurred in 1700, long before European settlers arrived. It was a seismic event of unimaginable power, estimated to have been a magnitude 9.0 or greater.
The earthquake unleashed a tsunami that devastated the Pacific Northwest, leaving its mark in the geological record and the oral histories of indigenous communities. The Ghost Tsunami of 1700.
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 The Ghost Tsunami of 1700.